So what we're looking to do today is talk about this. So if we look on the board, there's some things up here that have names. There's some stuff here you've done before. Does anybody either have a memory of how to do this or remember what any of these pieces to these problems are called?
Is it like square or cube?
Okay, there can be squared or cubed in some of these, not all of these, but on some of these problems we can use the word squared and cubed. We'll put that on hold for a second. Do you have an idea?
It's like 3 over 5 times.
Say again?
3 times 3 5 times.
Yeah, so this means to go 3 times 3 times 3 times 3 times 3. So we want to multiply until there's 5 3's there. That's what this means. So we're going to multiply a whole bunch of 3's, and in the end there's going to be 5 total 3's. Sometimes people misunderstand this and they think they need to multiply by 5 more 3's and end up with like 6 of them. That's not correct. But we've got 3 times 3 times 3, lots of 3's because the 3 is the main number here, and then the 5 gives you a count of how many there would be. Anybody else know a name of anything here to any of this? We're hunting 3 names for this world. Exponent is a word here. Is the 3 the exponent? Is the 5 the exponent? Do you have an opinion on that?
5.
The 5. The 5, one word for the 5 can be called an exponent. That is true. The 5 has another name. The 3 also has a name. Okay, the 5 could also be called the power. So if we're going to read this, we can read it as 3 to the 5th power, or you could just say 3 to the 5th if you like. This name, fewer people usually know that name. Does anybody know the name of what the 3 is called? It's a short B word. No go? That's called the base. So the base tells you what number you're going to use over and over and over again. The power, or the exponent, tells you how many there's going to be. So let's do this one, and then let's go back to that idea of squared and cubed. Can anybody do this out? If your quick answer is 15, did you do the right or wrong thing? Wrong. That's a common mistake. What did somebody who says 15, what did they do by accident?
3 times 5.
They did 3 times 5. That's very different than 3 times 3 times 3 times 3 times 3. That's not the same as 3 times 5. It's going to get much bigger than that. Can anybody get that one going? Grab a scratch piece of paper if you have to. Go pencil paper if you need to. That probably gets too big for everybody to feel comfortable just with mental math.
48.
Disagree?
162.
Disagree? I agree with 243. There's lots of different ways you could group this up. You just have to do whatever you're comfortable with. Most people are comfortable, I would think, with 3 times 3 makes 9. I think most people are still good with 9 times 3 makes 27. 27 times 3 is where we start to maybe lose our grip and have to grab pencil and paper. If you went down that road, what's 27 times 3? 81. And then you'd have to go 81 times 3. That's a way you could get 243. That's maybe not the best way for everybody, but that's a way you could go, is keep going 3 times 3, get an answer, times 3, new answer, times 3, new answer. Another way you could do this would be to group it up. 3 times 3 we were comfortable making 9, times another 3 we were comfortable making 27. So go that far and then give up for a minute. Because we're still comfortable with 3 times 3. 3 times 3 makes 9. So we could go 27 times 9, 27 times 9 would still get you 243. So you don't have to keep going bigger, 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 bigger. If it starts to get a little big and you're like, I don't like this, stop, do the rest of it, and then worry about putting the pieces together. Nothing wrong with that. 3 times 3 is 9, times 3 is 27, then temporary give up. 3 times 3 is 9, then worry about multiplying your 2 little pieces to make a big piece. Squared cubed. Can anybody talk to me about squared cubed, how those words can come into play? Anybody remember that? Squared is another name for a certain power. Sometimes you see it, sometimes you don't. It is a 2. So this problem I could read as 5 to the second power, or I could read it as 5 to the second, or this is where I can use the word squared. I can call this 5 squared if I wanted to read it that way. 2 power means squared, squared means a 2 power. How does cube then factor in? Anybody have an opinion on that? The 3 power is cubed. So what would be one way I could read this problem then? You guys are sleepy today. I could say 4 cubed. What's another way I could read this problem and it mean the same thing? 4 to the third power. What's another way I could read that problem and mean the same thing?
4 times 4 times 4.
Well, yeah, but that's not how I would read it. But that's true. What's another way I could read the problem if I wanted to say, write this down? 4 to the third power, 4 cubed. There's another thing I could say that would make you write that down. Anybody? Just 4 to the third. You don't have to say the word power, but you can. So if I said 4 to the third power, 4 to the third, or just 4 cubed, it would all be this. What this does mean is 4 times 4 times 4, that's not 12. Somebody do some stuff there with 4 times 4 times 4?
64.
It is 64. 4 times 4 is 16. 16 times 4, you might need pencil and paper to do that. That'll turn you into 64. Squared is the easiest power because there's only 2 of them. 5 squared means to do 5 times 5. 5 times 5 makes 25. That's not the same as 2 to the 5th power. If I swap these numbers, if I swap the base and the power, that makes a very different result. What's 2 to the 5th going to mean for us to do?
2 times 2 times 2 times 2.
Agree. So 2 times 2 times 2 times 2 times 2 times 2. When the base is small, that's easier. This is an easier one to do than the 3s were. The 3 was a bigger base, so it got bigger faster than the 2 will. Somebody get us that one?
32.
It is 32. 2 times 2 is 4. 4 times another 2 is 8. 8 times another 2 is 16. 16 times another 2 is 32. That would be a fine way to do it. If you wanted to avoid 16 times 2 and didn't want to use pencil paper, just quit. 2 times 2 times 2, we had 8 for that part. 2 times 2, we have 4 for that part. 8 times 4 is 32. That's a fine way to do it. 2 to the 10th, I don't want to write it out on the board. Okay, but if I did write out 2 to the 10th, what would I write?
64.
No, not 2 to the 10th, no.
2 times 2 times 2 times
How many?
10 times.
10 of them. I'd go 2 times 2 times 2 times 2, there would be 10 of them. Somebody take a minute and try to come up with that one if there's 10 of them.
64.
It isn't 64. It's going to be bigger than 6. If I go 2 to the 6th, that would get me to 64. But it's going to keep growing, growing, growing from there. You know what? I will write it on the board just to do it. So I've got time. 7, 8, 9. I'll say maybe, and because there's some other people going. I'm not saying yes, I'm not saying no, but let's get a second and third opinion on that. You said what? 1024? Anybody want to back him up or shoot him down? He says 1024, so he agrees. I'll still say maybe, but it just became a stronger maybe. Wait for one more person with an opinion. Anthony? You made a sort of like that. Looked like a hand, maybe, maybe not, I wasn't sure.
1024.
You got 1024. I'm going to agree with 1024. How did you do it when you did yours first? Did you just keep going times 2 times 2 times 2 the whole way?
I did 32 times 72.
Okay. How did you do yours? Did you just keep going times 2 each time?
I went from 64 and then 128 to 256 to 512, and I just said, oh, it's going to be 10.
Yeah, no, that's fine. So 2 times 2 times 2 times 2 times 2. Once we had 5 of them, we're up to 32. That's where we left off in the previous problem. So you got 2 choices, and they're both fine. They'll both get you the same answer. This, one choice is go times 2 again to 64, times 2 again to 128, times 2 again to 256, times 2 again to 512, times 2 again to 1024, and we hit it. That's fine. Another way you could do it is we knew these first 5 made a 32. So the next 5 have to make
32.
another 32. So not worried about going through those numbers. If the first 5 made a 32, the next 5 have to make a 32. You could just do out with pencil paper 32 times 32. That would give you the same result. Long story short, again, for the second or third time I've said this, it doesn't matter how you group them. So if you went 2 times 2 is 4, times 2 is 8, times 2 is 16, and then you got uncomfortable, stop. That group is 16. 1, 2, 3, 4 more of them is another 16. 2 times 2 is 4. If you want to now do 16 times 16, see what it is, and go times 4, that's fine. You can group them up however you want to group them up. Wherever you start to be like, I'm losing my grip, then stop. Get another group going. Question about those? If 10 is the base, there's something that happens. So let's go 10 squared. We'll do a couple of these, and we'll look for a pattern. So 10 squared, how would 10 squared end up?
10 times
Okay, which will make
40.
100. 10 squared is going to get 100. 10 to the third. 10 times 10 times 10. How would 10 to the third play out?
It would be 1,000.
It would be 1,000. There's a pattern to this when 10's the base. Can anybody tell me what you think 10 to the 12th would look like? Without having to do it out. If you do it out, it's going to be a lot.
10 trillion?
Describe what you think that'll look like.
Oh, no, 10 billion.
Describe it to me.
Because there's 4 zeros.
So you're going to want, so what am I going to write first?
10 times 10.
No, I'm just going to write the answer. What's the first digit of the answer?
10.
Well, it's 2 digits, but
There's 3 zeros. 3 more zeros. And then another 3.
that
That might be it.
might be it, he says. I'll say maybe.
Just add, put 1 in, add 12 here.
So you're saying this.
That's 12.
No, that's 9. You're saying that. Anybody want to agree or disagree with anything we're saying here?
I'll agree with them.
You agree with that one?
Yeah.
I'm going to agree with that one. Because what's the pattern here we're noticing? What happened here on this one?
Well, there's 2 zeros. But
There's 2 zeros, 2 power. This had
3 zeros.
3 zeros, is 3 power. So we're expecting this should have
12 zeros.
12 zeros because of a 12 power. Commas would help our life. That only works for tens. If 10 is the base, the power will tell you how many zeros there ought to be. You don't usually see this, but if I go 10 to the 1, what do you think that should be?
10.
Just a 10, because the 1's telling you you should have 1 0. There's a truth to this. If you have any number in the world and you take it to the first, what do you think would happen? Anytime, any number you have in the universe to the first,
It's going to just be the same.
it's going to be itself. That is true. Anything in the world that goes to a 1 power, it's just itself. There's another truth that involves 0 as the base. Can anybody say with words, like what is a truth about doing exponents if 0 is the base?
It's always gonna be 0.
Yeah, 0 to any power is always going to be 0. Yeah, I'll say almost always. 1, there's a truth if 1 is the base.
Oh, is it
It is. 1 to any power is 1. That will always be true. This rule gets in competition with another rule that won't affect your life till a future math, but I'll just throw it at you today. If we do anything to a 0 power, it's supposed to be 1. And it almost always is. But these rules get in a little bit of a competition. What oddball problem would these rules have an argument about?
It'd be like 1 times 0.
That
Like 0 times
0 to any power is supposed to be 0. That's supposed to be a rule, and it pretty much is. Anything to a 0 power is supposed to be 1. That's a rule. It pretty much is. But there's an argument between the rules.
So like, say, well, like,
What weird
it's
problem
like you can't,
would cause an argument?
for the bottom number, you can't, like, it's 0, so you can't even put like 1 up there.
Anybody, can you identify a weird problem that these rules would argue and there'd be a,
0 times 0?
not 0 times 0, but 0 to the 0, okay? This rule was telling you if 0 is the base, it's supposed to be 0. This rule is telling you if 0 is a power, it's supposed to be 1. So if I do 0 in both positions, it's kind of like, you could argue about it and you could think you're right, but it's a conversation for another day. This is called an indeterminate form. It basically means this is more complicated than you think it is. Let's argue about it when we know more math. Okay? There's another problem that's like that I could talk about real quick. Nothing to do with today, but 0 dividing 0, you could cause a big argument about. It's another thing called an indeterminate form. It just means it's too complicated. We can't talk about this in 7th grade. Let's just wait. We don't know. But what's something you could argue that this should be?
0.
0. Why could you argue that? That is potentially an argument you could feel like you're winning.
Because, like 1 because 0 is 0.
Okay, you can argue for 1. Okay, I'll go with that. You changed your mind in the middle of your own argument. Usually when stuff divides itself, what is it usually? 1. But what's usually true when 0 divides stuff? 0. And if you ever divide by 0, we haven't talked about that this year, but dividing by 0 is generally not allowed, and that's a math symbol that generally will mean you're not allowed to do that. So this is a problem that also creates an argument. Some other day we'll talk more about that argument, but not today. But back to where we are. 0 to any power is pretty much 0. Anything to a 0 is pretty much 1. Just this problem kind of blows out both of those rules, so I don't want to talk about that right now. That's good enough for now. Question about those ideas so far? Okay, if I go 3/5 to the 4th, what would 3/5 to the 4th look like?
Oh, like 6. Because I thought blocks the top.
Nah, 3/5 to the 4th. What do you think? How can we do 3/5 to the 4th? Absent a couple of our usual talkers today. Yeah, go ahead.
3/5 times 3/5 times 3/5 times 3/5.
Absolutely. 3/5 times 3/5 times 3/5 times 3/5. Absolutely true. So if we're going to multiply fractions, sometimes we cancel. Can we cancel here? No. Even though we've got a lot of matches, the tops only match the tops, and you're supposed to cancel tops with top numbers can only cancel with bottom numbers, and that's not going to work out. So can somebody do out some 3s, do out some 5s, because we're just going to have to multiply straight across. Top, anybody? Let's just go yell out pieces. 3 times 3 makes 9. The other 3 times 3 makes another 9. A couple of 9s is 81. For the bottoms, a couple 5s is 25. The other couple 5s is another 25. Then it's just a question of what's 25 times 25. You might need pencil paper to do that, I don't know. I'll give you a trick that I use to do 25s. I think about quarters. So if I had 20, quarters are 25 cents. So if I have 25 quarters, how much money do I have if I have 25 quarters?
$4.
25 quarters.
Is it 425?
It isn't, no. 25 quarters, anybody?
$7.50.
No, that's too high. How many quarters do you need to make $1? 4. So if I have 25 quarters and every 4 quarters makes $1, how many dollars do I have off of that? Yeah.
$6.25.
I'd have $6.25 because it takes me 4 quarters for every dollar. 4 into this goes 6, so I'd have 6 like full dollars, and then I'd have a leftover quarter. Sometimes counting quarters is a way you could do the mental math of 25 multiplications. But just use pencil paper if you need to. 25 times 25, it is 625. But if you like mental math, multiply 25, it's like counting quarters. 4 quarters for every dollar, so on and so forth. So if I had to go like 80 times 25, I would just think to myself, if I have 80 quarters, how much money do I have with 80 quarters?
That's like $50.
It is not. How many quarters for every dollar?
20.
There's 4. 4 quarters, I got 4 quarters per dollar. There's 80 quarters total. That makes $20. So that would be like 2,000 if I multiplied it. Let me do 1 decimal and then we'll call it a day. If I go 0.3 squared, what's 0.3 squared going to mean for us to do?
0.3 times
0.3
0.3.
times 0.3. When we multiply decimals, it involves counting who's to the right. So if I go 3 times 3, 3 times 3 is still 9, as it has been all period. It's just a question of where to plot the decimal. It is 0.09, because we have to count. There's 1 digit here to the right, there's 1 digit there to the right. To make 2 digits to the right, we're going to need a 0 to make that work out. We would need 0.09. That's our day. Exponents, powers, or that top little number tells you how many there ought to be. The base is the number that gets repeated over and over and over again. If they want to use words, the third power, I didn't even write it down over here, third power was called cubed, second power is called squared. They like to use those words in the book sometimes. If they give you a high power, I'd split the problem up into chunks. If they give you a lower power, mental math your way through. If 10 is the base, our shortcut is just write the 1 down, and then the power tells you how many zeros there ought to be. And then a little bit of trivia, anything that goes to the first should be itself. 0 almost always to any power is 0, just don't try to do this problem. Anything to a 0 power is 1, just don't try to do this problem yet. But we can do this every time. 1 to any power is 1, that's just absolutely true. Questions, anything? Where we're headed, homework off of this bit of life is to a 215. 215, we're just going to do everything. There's letters A to J, there's numbers 1 to 25, so 215 is everything. There's still maybe between 15 and 20 minutes left, so get a start on that.